Okay, let's get rolling. This is the semi-precision lecture number 1, week number 1. And if you go and look at your Blackboard shell for this class, you should see this kind of a layout. Again, the announcements is kind of important because you see here my most recent announcement was posted a few days ago because I have changed the lab hours. There was an error on the schedule. So really all that's changed is that the posting for the lab hours on Monday is from 1 p.m. to 8 p.m., not 11. It was set to 11 a.m. But this is where, the top one will always be the most recent lecture. But as you go down, you'll see there's a tab for assignments. Again, the syllabus and all that we talked about last week. The lab and lecture schedule we talked about last week. You should be in these things right now. You should have started reading. You should get your module. This is how the assignments come out. So you'll see here, this one's called Mandatory Safety Assignments. I want you to take that. I want you to read it. Have to get through that, like right now. Because I need you to be able to go in there and machine without any kind of concerns regarding safety or unsafe practices. Obviously, for right now, the most important thing is our safety glasses. Okay? Don't be on that floor without safety glasses. We don't need steel-toed shoes. And it's better to have closed shoes, though. I don't really encourage or want to really see any open-toed sandals or things like that. That's not very good at all for our shop. So anyway, with that being said, whenever you see something like this, Tooling U or online readings, it'll be a course title, Intro to OSHA. There'll be a number after it, 101. And that, of course, is your Tooling U reading assignment. So again, you don't get at that from Blackboard. You log into Tooling U, you search for that title, and just start going through. It's basically a narrated PowerPoint, basically, with some animation on some of them. And there will be a test. But you should be in this already. The next thing I need you to do before we start doing work, and some of you already had a demo on the bandsaw, but if you didn't have the demo on the bandsaw, I need you to click on that link. And I did a quick video on how to use the bandsaw and some of the things that you need to be careful of. Very important on that bandsaw is there's a feed knob that should not be changed. I want that to stay right where it is. Okay? And then the video kind of goes through a demo on how that bandsaw gets used. Now there's something called Assignment 1 here. And again, there's more reading modules. I don't necessarily need you to do these all. I do want you to get to bench work and layout, though. Because our first assignment, I'm going to talk you through it today. And then next week, I will do a demo on layout. So it would probably be helpful if you read that. But as we go down this list, your first assignment in reading has these modules here. So I do want you to try to get to bench work and layout as soon as you can. And if you look at assignment 2 here, this is like a description, okay? Some assignments, like assignment 3, have documents attached to them. But this assignment is basically a written assignment. It's presented to you just as text. But what you're doing is not using the bandsaw until you've either viewed that or had a demo by me. But if you kind of look at the description, it says horizontal bandsaw, 2 blocks, approximately 1/2 by 1 1/2 by 2, material equals 1018. Using hand files, file the large faces of the block to clean up and make the surface flat within 5/1000ths of an inch. That's using hand files. File 1 saw cut edge perpendicular to the top and the 1 long edge. And I'll have a block here and I'll show you that in a minute. But these pieces will be used in the next assignment. So you got to do 2 of them, okay? And then this is the next assignment, something called Component 1001, something called Component 1002. So what you're doing is rough cutting, saw cutting your blocks for those assignments. Just one, rather cut 2 blocks, and you're going to file up and clean up 2 blocks. Now, if you use the bandsaw correctly, what I have is material that is a 1/2 inch thick. It's 2 inches wide. So that means you got to saw cut it 1.5 inches long. Okay? And a quick tour of the shop. As you looked around last week, I'm standing in the classroom right now. To the left of me is the shop, and if you go straight left past the 2 Mazaks, you'll see a material rack. And there you're going to have various kinds of aluminum and steel. 1018 is a kind of steel. It's a low carbon steel. It's easy to machine. But this and then aluminum will be the 2 materials you'll be using in this class and others in the first semester. So, given that you'll find the piece of material and it's a 1/2 inch thick, the saw cut material is 2 inches wide. They come in drawn out pieces of about 6 to 10 foot long, and they're stacked up in the board over the, in the rack right outside our inspection lab. Now you're going to cut it as little as you can over 1.5 inches. So you're going to cut it maybe 1/16 of an inch or 1/8 of an inch longer. Okay? And then if you look at the assignment, you're going to cut yourself 2 pieces. So in the bandsaw demo, it shows you how to set that and you know, set your piece, measure your piece, cut it. And what you're going to then do is, and I'm going to bring up a PowerPoint in a few minutes, you're going to use whatever files you deem appropriate, hand files. So this larger one is a coarse, double-sided. This one is a finer, single-sided, single cut. And the idea is that we have vices all around the shop. In the back room, in the grinding room, there's a couple of bench vices. We should have a couple out here somewhere too, but definitely in the grinding room. The first thing you're always going to do when you rough cut, you can't really see it on this video, but all your corners where you've cut have sharp burrs on them. Very sharp edges that get pushed out as a tool goes through and cuts material. These are razor sharp and they're very hazardous. So you always, for whatever class, whatever kind of material you're cutting, you're always going to deburr it before you do any other machining to it. Always take the burr off the machine, off the part. And the way you do that is you get yourself a nice file. You put it in a vise typically, because sometimes the burr is pretty big. But what you're going to be doing is using the file, and you're going to just knock off the burr on all edges. This one has a really big burr, so it would actually be more appropriate to have this in a vise, but I'll just do it by hand as we stand here. So your technique is basically you're going to be filing the part, and all I'm doing is holding it in my hand, sliding the file up and across the edge as I go. I'll come a little closer to the lens and over here. And what I'm doing is I'm taking off the burr on all of my edges. The other reason you do this is because this burr, if you're going for precision machining and trying to hold a tolerance, you can't have a burr in between the part and where it's sitting. You always have to be free of burrs, and then you're going to be guaranteed the part's going to lay flat and soundly against any work-holding device you have. Pretty much the way you use a file if you have it in a, and you're going to need to put it in the vise to do the surfaces, but you'd be using it like so, okay? Standing and taking a good solid stroke with that thing in the vise. But I'm just knocking off the burr right now. We also have tools, it's like a hook tool, it's called a deburring tool. Those are kind of handy. We have a couple of those in back. Files you find in the snap-on cabinet, that aqua-colored one. And again, it's very important to always take your burrs off all edges. And you give them a nice clean up even across the factory edges. because the number one rule is you got to have clean parts, you got to have clean tables, and that means clean meaning not only are they removed of all grease and oils that have thickness, but the edges are clean, deburred, and then you'll be assured it will sit flat on a table. And all you really got to do is run your finger gently across a corner. You'll feel the burr right away. It's actually like a razor blade, very sharp. Sometimes people drop this stuff and your first instinct is to catch it. Not a good idea, because they are very sharp. Let it fall, let it hit the ground. Move your toes out of the way if it's a bigger part, but don't try to catch things that fall off a table. End mills and sharp cutting tools, if they fall, don't try to catch them. They will cut you so fast. Let them fall. They might break, they might not, but you will save yourself a little blood, because it's almost guaranteed if you just nick yourself with that on a fall, it will cut you, and it'll cut you pretty deep. Burrs are a big problem. So now my part is I've knocked off all the burrs. And if you're not sure, just ask me, and I'll tell you whether or not you've deburred it well, but I think you'll know right away. So this part has now been cleaned, all right? You also inspect it along its surface. If there's any, sometimes the material gets mishandled or it falls, there's little divots pushed out. You just definitely want to always clean up your surfaces as well. So not only are you knocking the burrs off the edges, but you're going to clean up your surfaces as well. The factories these days do a really good job. What this steel is called cold rolled steel. It's basically red hot ingot of steel. There's rollers up and under, and this steel gets kind of rolled through right to size. And they're fairly accurate. These rolled pieces from the factory are spec'd out as 1/2 inch thick, 2 inches wide. If you were to measure it, it would probably be within 10/1000ths of an inch. Definitely not smaller, maybe a little bigger, but it won't be smaller. Yesterday, some of you used the 1 inch diameter, and you measured it, and you saw they were a little bit oversized, aluminum. You know, rough material is always a little oversized, but you can pretty much count on it not being under. If it is undersized, you send it back to where you bought it from and tell them you got a bad piece, because they shouldn't be under. Okay, so this all comes from the bandsaw. Edges get cleaned up. And now let's look at the description of the using hand files. File large faces of the block to clean up and make the surface flat within 5/1000ths. So what that means is you're going to take your block that you just cut and deburred. You're going to put it in a vise, like so, with the top extending just past the jaws of the vise. And if you imagine a vise being right here, what you're going to do is you're going to work these faces. So what you start off with is, this is a rough file, and I'm going to talk a little bit about some of the hand tools we use. With this in the vise, you're going to be working this edge and filing it flat. Okay? We want this face to be flat so that when I take the machinist square and put it up and hold it to the light, I don't want to see any sort of bend, curve going inward or upward. I don't want to see it rocking. It needs to be flat within 5/1000ths. And what we can do is we'll eventually just run this. This is a machinist square. We have 2 of them in back. But as you hold this up to the light, you'll want to not see any sort of cracks between this and the surface. So although I'm holding it in my hand, the best way to do it is to do it in a vise. And so if the piece is like this, you're going to file across the face like so. Okay, you're going to have both hands on it, and you're going to be working it like that. Now this is a double cut file, so what some people do as far as the technique goes, they'll kind of, if you can see it from here, kind of hold it in their hands, and this one can be used this way because it's a double cut. the edges are doubled. Or you can just use it in one direction. But you'll see, and you're not going to be scraping it like that. It's really just like saw cutting. Longer strokes are better. And what you want to do is those strokes have to be flat, because if you're stroking like this, you're going to round your part, right? Over or under. So the assignment is to machine the two large flat faces, or file them rather, to within 5 thousandths. So whatever time it takes, you'll do that. Again, this file can be used like so, with both hands on it. Nice strokes are better. So those are the two surfaces. And the way you inspect it is you just take that steel square and put it up against your part. Now these files are perfectly flat, so if you stroke with them flat, they'll do a good job for you. What we don't want to see is you coming off the edge, just nice and flat. And you can take a look at this block later and you'll see that there's just a few scratches all through it. But now it says, using hand files, file one saw cut edge perpendicular to the top and one long edge. So what does that mean? That means that you look at the edge that you saw cut. You use your machinist square, and if you put it against the square like that and put it up to the light, you're going to see the face is either going to be like so or like so. So when you look down this end, what you'll be seeing is, there's your material. Your square is going to be, your material is going to be a little bit so here's your square, but you're going to have this little bit either on that side or on the other side, because the saw is not perfectly straight. It will always wander a little bit, even on a short, small piece like that. So as I take this, put my face, my large, longer face that I just filed nice and flat up against the back of the machinist square, and I look down, I see that this has a high spot here, and it kind of is like that. So this goes back into the vise, and it's a matter of squaring it off, holding your file square and flat, taking the high side down to make this perpendicular to that. So it's a little bit of filing you're going to need to do, and the way you do it is you'll have it clamped in the vise like that, and probably have this held like so, and you're just going to machine it. A little bit is all it'll take. If you went and cut the bandsaw, let the bandsaw cut the way I said at the speed, it will give you a very good result, and it won't be very much filing at all. So then at the same time, we want to make it perpendicular to the side as well. So that means I take the square, put it up against the part, and now look at it through the light. Oh, and that saw did a fantastic job. Very little on this. So this is perpendicularity to the edge, perpendicularity to the face. So the saw cut it nice and straight. There's very little gap or light showing through. But there is a bit of taper. Oh, this is even pretty good. Now you only need to do one saw cut edge, okay? You don't need to do both of them. Just clean up one edge so that it's perpendicular. This then will become what we call your reference edge. You will have the face, the side, and these three corners, and then you're going to put a little mark on there so that we know that that's the cleaned up face. All right? So we'll demonstrate all of that in a moment. So given that, you got to do that to both blocks. Only the one saw cut edge though, and then that saw cut edge is used against the stops of the drill presses and whatnot, and you'll be doing layout. Okay, so now let's take a look at component 1001. I realize some of you might not be able to read blueprints just yet. But what this is showing us is the block we just machined. Okay, here's the length of it. This is that 2-inch length. This is the height, 1.5 inch. And then this is our thickness. So you look at the part like this, and then it comes out of the screen like that, and it comes up like that. This is what we'll talk about a little later today in blueprint reading. But all we're going to need you to do is from one particular corner of the part to measure and inscribe these dimensions into the part. You're going to prick punch it, you're going to center punch it, and then we're going to drill the hole. And what I want you to be able to do eventually is to hold about 15 thousandths of an inch. So when I measure where this hole is in relation to this edge, it will be within 15 thousandths of an inch. So as much as 1.015 that way, or as little as 1.85 or 0.85 this way, or 985 rather. So there's tolerance in there. And generally, we're in semi-precision machining. Semi-precision implies a tolerance of plus or minus 0.015 of an inch. That happens to be the decimal equivalent of 1/64th of an inch. Okay? That's your sort of working tolerance with semi-precision. Now filing, I spec'd out in the assignment 5 thousandths. That's pretty easy to do with this material in a file. You should be able to see, that it's very nice and flat. But that's all this assignment is a layout. And then we're going to take it to the drill press. We're going to do what's called center drilling. And then we're going to do a pilot drill, or a step drill. And then we're going to go with a 1/2 inch diameter drill. In steel, this is not like wood anymore. Steel is now much harder to machine. So what we do generally, if the hole is larger than about 7/16 of an inch, or getting up to a 1/2 inch, you give it a smaller hole first, we'll call a pilot hole or a step drill, and then you come back with a full 1/2 inch diameter. So you let the smaller drill come and kind of work its way, and then you come back with a 1/2 inch diameter drill. That's what this means. 1/2 means 1/2 inch, DIA, I know it's hard to see from back there, but diameter, and it's a through hole. So that's what these little lines show. They show the extent of the hole, and it goes through the entire thickness of the part. So how's that sound? Pretty good? All right. Any questions so far? I'm sorry?
I got all of it.
Got all of it? Okay, great. Then let's take a quick look at some of the hand tools we'll be using around the shop. And then that'll be it as far as lecture goes. And then you can go and do a bit of this work, or you can do turning or milling, whatever you've started. But now let me just bring up the slide. So semi-precision is really an exercise in using different hand tools to machine fairly precise and accurate parts, being to about tolerances of plus or minus 15 thousandths. Angular tolerances plus or minus about 5 to 10 degrees are very common. And so you're going to say, wow, a machine shop, why do I need to worry about hand tools and files and things? Well, sometimes your career might find you in a position where you have to go somewhere remote outside of a shop, perhaps to do a repair in a field. I know that a lot of equipment that works out in agriculture in the field, it will break, and sometimes it's just a very quick fabrication that you need to do as far as a repair out in the field, because you can't drag along a big giant drill press or a milling machine. So there are still those kinds of jobs and such that require ingenuity. And as in all things, when you're doing work that is of a complex nature where many different assemblies, especially with dies and molds, there's always going to be massaging of a part. If you're dealing with a mold that has a free form flow going from one set to the other, the upper and lower die halves, you have to usually hand file it so that, because consumer products being what they are, they wouldn't tolerate seeing a plastic seam in between your two mold halves. So you're going to be in there with what's called die file or a die grinder, and it's basically a very fine piece of handiwork that you do, because it doesn't always come off perfectly matched in many shops, So there's always a need for the skill of understanding to take a round file and open up a bore, That's a very precise, accurate hole, and you might have to just do what they call lapping, very fine bit of filing to open it up so that a pinion can go through it, for example. So we talked about, these are common tools that you have around the house. We have them here: screwdrivers, Phillips heads, flat heads, square drives, Torx heads, posi drives. There's all kinds out there these days. Different kinds of pliers and squeezers and cutters. Hammers, ball peen hammers. These we have a lot in the shops. Ball peen is sometimes needed to coax a stubborn shaft where it might be seized inside of a block. You can kind of coax it out of there. Hammers are usually specified in ounces: 16 ounce, 10 ounce, 8 ounce, meaning how heavy it is. We don't use these very much in the shop, except where we're pounding out a pin or something like that. Certainly never ever going to use this kind of a hammer to do vise alignment, okay? We're always going to use our soft, non-kickback hammers for adjusting the heads and vices and things of machines. And we never use hammers to pound vise handles to make it tighter, okay? Those are all bad practices that I don't really want to ever encourage anybody to start. So we're going to make sure we don't start them. These are dead blow hammers. We have some of these laying around. These are the preferred hammers for adjusting vices. They, are plastic, so they won't ruin the steel. Different other kinds of soft face hammers. What's up?
You can go to Flash, copy or printer problems.
Printer problems? Oh, there's the printer.
All right. Sounds like it was. Let's see what it was doing. It's making noise. Sorry.
It doesn't sense when the cartridge tray is in. There's obviously a sensor.
Okay.
And you gotta sit there and.
Is that for the paper tray? Right?
Yeah.
Okay.
Yeah. Right, Leo? Isn't that what we had to do yesterday? Bring it out, bring it in. And it's been doing that since the day it was here. So now it's just worse.
Okay.
So we got soft face hammers, and we have open end wrenches, box wrenches. We use these all over the place. You've seen us use a couple of them yesterday on the lathes. Crescent wrenches. I have a lot of these around the shop. They're not so good. I mean, it's not a good solution, because you've got to be really careful with these crescent wrenches, especially when they get worn. You've got these jaws that are adjustable, right? You don't want this to be the jaw taking the force. You want it to be against the solid part. How many times have you been using one of those and just slipped off and ow? So they're not the best solution, but we have tons of them, so we kind of have them all over the place out there. But here so you see the direction of the feed, and you want that force pushing up against the solid part. That's kind of really the only thing to watch. Socket heads, I'm sure you've used a lot of these. And then those of you watching on watching online. Hex heads, Allen wrenches, very common things around the house. Different configurations, all the same thing. They're 6-sided hexagon wrenches, typically called an Allen wrench. So here we have, they call it the tang, and then the length of the file, the face of the file, the edges, and then the heel is where you can see if it's a double or a single. So here's a lot of little specialty files. We have a bunch of these around, but they all have particular uses. So if you're working on rounded surfaces, use a triangular file. I like these knife files. They work really good, but there are a whole bunch of configurations. And here are the sort of more, you see these more in soft metals, but what we're here is something called a double cut and a single cut. Double cut is the one that I had in my hand. That was this longer one. That means you can cut forward and backward, or you can slice it like that. This one here is a single cut. You'll see that at the base. You'll see it at the base. You can actually see that there's two, and this only has the one. They're only made to go in one direction. File, 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 so on. These are more specialty files. We don't have a whole
double.